Hi guys, welcome to NLP series. So today guys we'll be talking about neural networks and yes guys, if you are watching this lecture, that means you're like perhaps going to study the most important topic of today's history. So this time guys, two Nobel prizes specifically in physics and chemistry have gone to people who have worked on neural nets, and essentially whatever they have built and the real foundation or the true ground of it is nothing but is neural network only. So guys, essentially what is neural network guys? It's very intuitive lecture because we are doing NLP series, and as I said that I want to make this series very modern and specifically directed to LLMs, but it's always good to understand basics a bit specifically for neural networks. In-depth series also I'll be launching. Yeah, so that's pretty much it on the plans. Now let's just quickly get started, and guys, see, you studying something that's perhaps being awarded Nobel Prize, so you should be very happy and very proud of yourself. So guys, the first thing that is there is what is a neural network. So guys, see, from where I'm coming from is mind. So essentially guys, the main idea which a lot of researchers are trying to target is how does your mind work. So this exactly is a branch of neuroscience. Okay, if we can understand how does the brain work, we can essentially create systems which also have brain. Okay, so that's the main goal. Can we build any system which has human like tendencies? Human like tendency. So guys, what is human like tendency? See guys, we humans are very special. That's a point of debate, right? Can today's LLMs reach there? We humans are very special. The idea is that essentially the idea is that we learn. Okay, how do we learn? Let's say someone teaches you that whenever you are seeing a green light, you should keep moving. Whenever you see a red light, okay, whenever you see a red light, you should stop. From where have you gotten these instructions? You have gotten these instructions by someone. Okay, so exactly what happens is guys that in simple terms the problem statement is that when given data of any nature, this is very important guys, this term any nature, essentially what happens in ML and a lot of statistical models is they have a lot of assumptions. Okay, and sometimes tabular data may follow such pattern as well. So maybe going for ML and statistical approaches might make sense in some cases, but guys, in most of the cases it doesn't follow any, it doesn't have like the data set which you have might not fulfill all the conditions so that you could apply a statistical model, and then you have a lot of you have nothing but you have a lot of raw data. Let's say text, you have text. How on earth can you even think of modeling text? So guys, essentially what happens in a neural network is, okay, I'll be going in my way. So what happens in a neural network is you have something known as neurons. So let's just create a very simple neural network for educational purposes. So this is a very simple basic kind of neural network. So what happens is that what usually happens is over here is you have an input that comes in. So let's say the input is 1, 2 and 3, and here the actual output is, you're doing a binary classification, here the output is 1. Okay, so what will happen is guys, data will pass through this node and here you will have weights. Okay, here you will have multiple weights. So you will have one, two, so you will have three, four, five and six. So you will have six set of weights. You will have six set of weights and you will have weight 7 and weight 8 over here as well. And essentially what will happen is guys, this thing would come here and this what would be inside, what would get inside of this would be summation xi wi. So guys, this is very important. Okay, for the time being I'm not talking about biases. Yes, there is b also, so you can include that as well, but essentially the main idea is to have summation xi wi. What is summation xi wi? Next question. Simple guys, see, this is your xi, this is your wi, these two will get multiplied, and here you have I think here you have 1 2 3, so you will have three neurons that are connected to this thing. So what would go inside it would be summation. It would be, let's not write summation, let's just show you what would go inside this thing. You will have 1 into w1, 2 into w3 plus 3 into w5. What are w's? Okay guys, very important question. See, w's are nothing, these are weights. What are weights? Weights are nothing, these are random values. And later on, like later on, once this forward pass happens, essentially we have a loss function, and based on that loss function these value of weights get updated, and they get updated in a sense that they can capture the essence of the data set. Okay, now let's just try to see some notes that I have prepared. So as I've been stating, that what happens is that you have wxb. So let's say you have a single thing, so here you have input as something input, and let's say x is your input, this is your w, so this would get multiplied and this would go inside it and you would add a bias to it. And then guys, you have a is equal to f of z. What is f of z? See guys, what happens is, where neural networks actually win is that they have something known as, so what happens inside a single neuron. So we have x, that is the input that goes inside it, we have a set of weights. Okay, these two would get multiplied, so z is nothing but xw plus b. Now exactly what is the output? So let's say o is the output, o is f of z. What is f of z? Guys, this is activation function. So guys, in neural networks, okay, in neural networks, essentially what happens in neural networks is that you have activation functions. These activation functions are essentially added to give you non-linearity. So now the main concept is that you'll have non-linearity. Why do you need non-linearity? Because guys, in order to capture trends, okay, in order to capture trends you require non-linearity. So guys, this is exactly what happens inside one neuron. Okay, and as I said guys, this is more like an introductory lecture to neural networks, specifically so that you understand some basics, so that you could contribute quickly in modern NLP. And a detailed neural network playlist would probably also come on my YouTube channel. So see guys, as I said, there are some other types of activation function as well. Okay, there are a lot of activation functions, and then you have network architecture as well. So guys, neural networks, like what I shown you, so what I shown you was a ANN. So you have ANNs, you have CNNs, you have RNNs, you have LSTMs, and then you have the latest ones as transformers. So guys, that's what I said, that in order to understand this, it would be a lot of theory lectures, which I don't want to cover, since this is more like a modern NLP series. And uh, practically guys, the idea is that there is a lot of stuff as well on internet, and I would want, if you want to go into that level of granularity, you can go, but for the time being, whatever I am teaching should be your first goal, so that you could exactly learn how to leverage LLMs in order to do a lot of NLP tasks, and that would be the main goal. So guys, essentially this is how we have progressed, and now we have transformers, and that's also a type of neural network only, which uses attention as its underlining heart, you can say. And because of this attention, It's able to capture relationships between words. Okay, relation, I've been stating this again and again. So because of this, it has been able to get relationships between words. And guys, if my model is able to understand relationship between words, it's probably having an understanding of the society as well, since a lot of stuff which is documented over the internet mainly covers what we are, who we are as a society. Okay guys, now the main thing or the crux of it is that I'm going to just conclude this to give you a quick glimpse that essentially what happens is that you have input data, you pass it inside a neural network. Neural network is guys made of a input layer. Okay, then you have an output layer. We'll probably see a lot of things in our examples as well. Here you have weights, all these values of weights. Here you have inputs, so inputs get multiplied by weights and then they get added up, and then guys post addition of it, they pass through an activation function, and that is how the output comes. Okay, in your last layer usually we have softmax. Okay, softmax activation function. So what happens in the last layer of a language model at the time of inference is that it predicts probability of next token. Probability of next token. So there are a lot of words which get generated, like, so let's say the has a probability of 0.9, then combined all of them would have probability of 0.1. So the next word that the model would throw in would be the, right? So that's essentially an important part that you need to know. And exactly guys, yeah, this is pretty much it on the basics and foundations of it. Just try to follow along the playlist. Just try to understand that you have an input layer, you have a hidden layer, and then you have an output layer. Everything is interconnected. I'll be explaining more in depth with my series on neural nets. And yeah, that's pretty much it. All these weights are learned with the help of backpropagation. I've been talking about backpropagation a lot in my NLP series. That's exactly W new is equal to W old minus learning rate of change of loss with respect to W old. And yeah, that's pretty much it guys. That's how backpropagation also happens. As I said, that some of you might be new to this field, so just stay along guys. Just try to follow along the development life cycle first, then we would go in depth of theory as well in specific playlist that's for neural nets, and yeah, we'll cover more on that aspect as well. And yeah, exactly guys, the thing is that neural networks are a big concept, right? I'm not sure how many lectures would it take to cover that in depth, so that's why I want to just give you a high level overview so that we can quickly get started on the development life cycle. Thank you, and guys, please subscribe to my YouTube channel.